All right, last example. Go along with the same idea. So this was the graph example for Carolina's wind chimes. Her neighbor, Kaio, uh, makes flower pots. Okay. And then he's making those flower pots based on that function, right? So that's the revenue function for his flower pots. Find the y-intercept of each function and who would lose more money if neither person sold any items. All right. So looking at Carolina, her y-intercept is 0, negative 64, just based on the graph from what we already knew about her function. So that means she would lose $64 if she makes nothing. Okay. Kaio, the y-intercept would be the value of the function when x is 0. If you substitute 0 in for each of those x's and you multiply them all together, you're going to end up with 0. So he doesn't lose any money by not producing anything. So the person who would lose more money would be Carolina. Same idea, but now we're going to talk about the end behaviors. Well, for Carolina, you can tell that the end behavior, just by looking at the graph, right? Really, we're only concerned about as x approaches infinity, because that's moving to the right. As x approaches negative infinity, now we're talking about producing negative amount of things, so it doesn't make sense. So we're only looking from 0 and up. For Kaio, we need, in order to determine the end behavior, we need to get it in standard form. So that's what we're going to see here. So again, the first thing we're talking about is, so if we're not talking about non-negative values, we're only talking about x as it approaches positive infinity. So for the graph, as x approaches infinity, y approaches negative infinity. As x goes right, y goes down. For Kaio, yeah, we're getting that function in standard form. For a cubic function, degree is odd. That means one side falls, one side rises, right? But since it's negative, that means it rises to the left and falls to the right. So it would also be falling to the right. So as x approaches infinity, so as x goes to the right, y approaches negative infinity, so y goes down. So they both have a finite number of items that they should sell to make a profit, meaning if they keep making items, they're not going to make a profit. Kind of makes sense because there's probably not an unlimited demand for wind chimes, right? So there's a sweet spot where she can make a certain amount of wind chimes and make the most money. Same thing with the painted flower pots, right? There's probably not an unlimited demand for those. So there's a sweet spot where he can make the most money, right? And it would be at the vertex. So same thing's happening here. You've got a graph and a separate function, and you're going to compare and interpret the y-intercepts and the end behaviors of those graphs. All right, so why don't you pause it, consider that, and then come back and check my answers. All right, so looking at the f function, y-intercepts at 0, meaning they don't make any money when they make no items to sell. Whatever they're making doesn't really say in the question. And the end behavior is that it goes up, right? As x approaches infinity to the right, y approaches infinity up. If I take the g function, again, you want to get it in standard form, the y-intercept is 0, 5, meaning they're going to make $5 for not doing anything. Not sure that's possible, but that's the scenario. But their end behavior is going to be as x approaches infinity, y approaches negative infinity, meaning as x goes to the right, y goes down. So why is that? Well, it's because the degree is even and the leading coefficient is negative. So essentially what you know, if you were to graph this, let's say that's at 5, this is an upside down parabola that does something like that, right? It didn't ask us to find what would maximize the profit, but it'd be whatever the vertex is there for the g function. For the f function, the more they make, the more they're going to earn, essentially, is how that's going to work. Because that's what the end behavior keeps going up. So they're limited just by what they can produce. All right. So try the exit ticket, and we'll go over that in class tomorrow. Let me know if you have any questions.